Currently, manufacturing processes in shipbuilding require a great amount of arduous and hazardous tasks. This is the case of two labor-intensive outfitting operations: pre-outfitting marking and stud welding for laying insulating panels or placing auxiliary equipment. Large vessels, like cruisers, may require over 5 million stud welding components. For an average rate of 10 studs per minute, this means that the stud welding process alone requires over 8,600 hours of work. In this context, the CARLoS project has demonstrated the use of a mobile manipulator to automate these tasks. To this end, CARLoS had to address a number of issues that challenge robot mobility, safety and reliability in a large semi-structured environment like shipyards. The initiative involves an international multidisciplinary consortium led by IMEN and is supported by the European Union through the 7th Framework Programme.
In the CARLoS project, we have developed a mobile manipulator to automate arduous tasks in shipbuilding outfitting. CARLoS robot is capable to navigate and weld studs inside ship blocks, and it features an advanced projection mapping interface that enables the operation by a shipyard worker without knowledge on robotics.
CARLoS has been developed using off-the-shelf components, focusing on software development and tool integration. Robot programming is based on skills intuitive and natural for operators for a flexible and easy use. As a result, the CARLoS robot is able to perform arduous and repetitive tasks in cooperation with human operators in a large, unstructured industrial environment such as a shipyard workshop.
Robotnik is a company specialized in service robot products, and Project CARLoS gives us new opportunities to introduce robot platforms in the shipyard building market. The result of the project can be a good introduction for new customers, and this could allow us to create a new line robots for the heavy industry.
For Valinia Shipyard, CARLoS project has been an opportunity to test a new mobile manipulation technology to facilitate and improve the working conditions of our operators.
The CARLoS robot may be operated in 3 different modes, depending on the accessibility and complexity of the task. To execute a task in the autonomous mode, the operator creates missions composed of different tasks, using the available robot skills such as welding. Afterwards, the operator just loads one predefined mission, and the robot autonomously defines goal positions based on the task to do and the bulkhead topology. Navigation in cluttered environments like ship superstructures poses specific challenges to mobility and autonomy. Path planning and reactive navigation are performed based on information from laser sensors and the CAD model of the ship block. Since the CARLoS robot works close to the bulkhead, it has been necessary to develop specific path planning techniques for the maneuvering of the mobile platform. In addition, CARLoS operates in shared workspaces with humans without safety fences. Based on laser sensors, CARLoS encloses the workspace and prevents any collision with workers or with other obstacles. To this end, configurable safety areas have been defined. Once the goal position on the targeted bulkhead section is reached, a vision system determines the actual positions of studs to weld. Stud welding is the most critical and complex process. This process requires proper arm positioning accuracy and good electrical contact with the bulkhead. CARLoS combines the vision system with a force-torque sensor system to align the welding torch perpendicular to the wall and to apply the contact force needed to guarantee a good electrical contact. In this mode, before the welding process starts, CARLoS projects the planned locations of studs and other equipment onto the bulkhead. In this way, CARLoS adopts an intuitive and cooperative approach in which the operator can interact with the robot in the workspace for on-site adjustment of stud distribution. The operator can examine the distribution in a large area with a remote pointer. This is possible thanks to the capability of the robot to refresh the projection in real time as it follows the movements of the operator. The operator is also able to confirm or modify this initial distribution. Thereby, robot and operator work in cooperation, allowing on-site replanning of the stud distribution. CARLoS can also assist the operator in a manual welding process, marking on the bulkhead the positions of studs and other elements.
At the end of the project, I can say that the know-how that the RTD performer will transfer to us, it will very important for us to develop a new product in the field of shipbuilding, but not only in this field.
With CARLoS project, Delta is looking for new skills concerning mobile robots, human robots, cooperation technology in hard industrial environment, like shipbuilding.
So we are deeply involved in the introduction of new solutions and new ideas in referring to the production and automation of all kind of process works. So we are really interested in this project and all kind of projects referred to the Industry 4.0.
Overall, the CARLoS mobile manipulator has demonstrated excellent ability to handle challenging operations in a tough scenario such as the interior of shipbuilding blocks, besides demonstrating a great flexibility and ease of use.